Absolute values. So let's look at a couple of these different points. These aren't problems, these are facts. I'm going to look at a couple of the ones that are probably easier to comprehend, like number 3. Number 3 says that the absolute value of x is always greater than 0 or it's equal to 0. So if you remember what absolute value means, it means once you're finished with the calculation inside of it, whatever number you get for the answer, you're supposed to make it positive. Now if you get 0 for the answer, 0 is equal to 0. Any other number that you get, you're going to make it positive, therefore it has to be bigger than 0, because numbers that are bigger than 0 are positive. Looking at number 4, this is saying that if you subtract two numbers, it doesn't matter the order in which you do it if you make them positive at the end. So for example, if I had 3 minus 4, or if I subtracted 4 minus 3, in both cases I'm going to get some version of 1, either a positive 1 or a negative 1. So then once I get that one number, negative 1 or 1, and I take the absolute value of it, it's going to be 1 equals 1. Number 2 is saying that if you put a positive number in here, well, let me rephrase that. If you put a number inside the absolute value, or you put that same number in but change its sign, no matter what number that is, the absolute value is going to be positive. So here's what it doesn't mean, which is what I started to say. This doesn't mean x is positive and then here x is negative. It means x is some number, could be positive or negative. This one here means that you change the sign of x. Which leads us to number 1, which is the most confusing. This says that the absolute value of x is equal to x if x is at least 0. So let me try to explain. For example, let's say that x was 5, because 5 is greater than or equal to 0. So the absolute value of 5 is 5. That makes sense, right? This one over here is a little bit more confusing. The absolute value of x is equal to negative x if x is less than 0. Most folks would look at this and say, no way, Jose, that's an impossibility. The absolute value is always positive. And you're right, it is. But this here doesn't mean that x is negative. It means it's the opposite sign of what's in here. So since we are choosing a number less than 0, such as a negative 3, if you put a negative 3 into this, this is saying on the outside it's going to be the opposite sign of negative 3. A negative negative 3, if you will, which would be positive 3. So those are some general rules for absolute value. Let's look at some examples. For what values of x is the absolute value of x plus 11 equal to 20? To solve an equation like this, we definitely want to get the absolute value and what's inside of it by itself first. I'm going to subtract 11 from both sides of the equation. It's going to give me the absolute value of x equals 9. Once that's by itself, you're going to separate this into two separate equations. One where you simply remove the absolute value, everything else stays the same. The other equation, you remove the absolute value, and the other side of the equation changes sign. So the values of x that would make this equation true is going to be a positive 9 and a negative 9. Let's look at a different example, a little more complicated one. For what values of x is 3 times the absolute value of the difference of x and 5 minus 4 equal to negative 2? Once again, we want to get the absolute value by itself, so I am going to add 4 to both sides of the equation. Negative 2 plus 4 is 2. Then I'm going to divide both sides of the equation by 3. Get the absolute value of the difference of x and 5 equals 2/3. Once the absolute value is by itself, you're going to make two separate equations. One where you simply remove the absolute value bars. So we got x minus 5 is equal to 2/3. The other where you remove the absolute value bars and you change the sign of the other side of the equation. We continue to solve these two different equations. Here, if we add 5 to both sides, we're going to get 5 plus 2/3. To add a whole number to a fraction, you need a common denominator. So I'm going to change 5 to 15/3. 15/3 plus 2/3. When you add two fractions, you add the top numbers and the bottom stays the same. Over here, if I do the same thing, I'm going to get 5 minus 2/3, which is going to be 15/3 minus 2/3, which is 13/3. So for what values of x would make this true? 17/3 and 13/3. Let's do another. If you're solving an absolute value and there's an inequality in it, it's very similar to an equation. You want to get the absolute value by itself and what's inside of it, just like we did for the previous ones. That's already done in this problem. Then you're going to make two different inequalities, just like we made two equations before. In one case, you remove the absolute value. Everything else stays the same. In the other, you remove the absolute value. The inequality sign changes direction, and you change the sign of the number that was over there. So now we're going to have x minus 4 is greater than negative 10. You solve each of these little fellas. Remember that if you multiply or divide both sides by a negative number, then it's going to change the direction of the inequality sign. So now we're saying our answer is x is less than 14 or x is bigger than negative 6. And to write that in a compound inequality, it would look like this. Let me give you a little bit more explanation of how I know that it's, this is essentially saying that x is between negative 6 and 14. One way you can do this, if this makes it more clear, is to draw a number line. Put each solution that you got on your number line. And then above or below the number line, shade in your answers. So x is less than 14. It's an open circle going to the left. X is greater than negative 6. That's an open circle going to the right. And at this point, I realized I made a mistake earlier. This should not say or. Should say and. And I'll explain why in a second. If it's an and problem, your solution is where your two other solutions overlap. And they're overlapping between negative 6 and 14, which is what this answer was saying all along. X is between negative 6 and 14. The reason we know it's an and problem, reading it from the absolute value first, this says the absolute value is less than. And if you exaggerate less than like a moron, you will get an and, less than. If it was a greater than symbol, you would exaggerate that also like a moron and say great or. So solution for this is right here. Let's do one more. Last problem, let's get the absolute value by itself. So to do that, we're going to subtract 10 from both sides of the equation. 21 minus 10 is 11. Then we are going to remove the absolute value bar in one case. In the other case, we're going to remove the absolute value bars, have the inequality change direction, and change the sign of the number that's over there. Then we solve each of these equations, these inequalities I should say. We're going to add 2 to both sides, and we're going to divide by 5, and we get x is greater than or equal to 13. So other one, we're going to add 2 to both sides, then divide by 5. We get x is less than or equal to negative 9/5. So is this a greater or less than problem? This is greater. Read with the absolute value first, so it's an or problem. So we're looking for answers that are greater are equal to 13, or they're less than or equal to negative 9/5. So if we draw a number line for this, got negative 9/5 on the left. It says closed circle because it says equal to. We go to the left. 13's over here. It's a closed circle and it goes to the right. So that means our answer is anything that is less than negative 9/5 or anything greater than 13, which we could simply write it like this. And that is our answer. Please do exercises 158 to 162.